This was a period when glaciers advanced globally. Agriculture failures were common. The Greenland colonies were failed. But it ended about 1900, and that started what we call the 20th century warming trend. And so we've had about 100 years of warming, and the characteristics of this warming trend are, it's rather bimodal, where we had warming up to the 1940s, cooling again through the 50s, 60s to the mid-70s, and then a second warming trend through the 80s and 90s. If we look at CO2 during that time, CO2 was a steady baseline at about 280 ppm in the atmosphere, and during this warming trend, CO2 rose up to about 380 ppm. Today, the warming trend that we're concerned with is really just this last bit, because CO2 in the earlier part of the 20th century was really too minor, and the IPCC and most scientists agree that this was all a natural warming trend here, and that this is potentially the anthropogenic trend. Is this 20th century warming unusual? Well, we go back to 1,000 years before present, and we see a warm period, which we call the medieval warm period, which occurred, centered on 1,000 years ago, lasted about 200 years, well documented by agricultural records. The Vikings settled in Greenland and came to Canada. So there's lots of documentation and proxy records for the medieval warm period, followed by the Little Ice Age and then 20th century warming. But during that period, we didn't see any effect of CO2. So CO2 was flat during this time, and so there's no correlation with this greenhouse gas. We go back further in time, here over the last 10,000 years, and this is the Holocene interglacial, following the past glacial period when glaciers covered Canada. And we see that here, the 20th century warming is one of a series of climate optima. There's the medieval warming period, the Roman climate optimum during the time of Christ, and then we go back further in the Holocene and we see various optima, warm periods of varying intensity and duration. So the current 20th century climate warming is really one of a series, is nothing unusual. Furthermore, throughout this period, CO2 was a relatively steady 280 ppm. So CO2 had nothing to do with these warming periods. We'll go back further in time, here looking at the record from ice cores in Antarctica, and these are very robust records of climate. And I'm reading from present day back 450,000 years. The records now go back closer to 1 million years, documenting interglacial periods. And here's our current, the Holocene interglacial. There's the last glacial period when glaciers covered Canada and many parts of Europe. And then our last interglacial, we have these series. Clearly, climate has been changing quite dramatically over this time period. And when we look at CO2, we see a very strong correlation. CO2 is increased during the interglacials, decreases during the glacial maximum period down to 180 ppm, back up into this last interglacial, again up to 280 to 300 ppm. So CO2 strongly correlated with climate, apparently. Well, we have to look more closely at this correlation, and this is where the science becomes obfuscated, particularly by Al Gore and other people promoting CO2 as a forcing agent. And here we're looking at a very detailed interface between a glacial period here at 245 to 240 and an interglacial period. So we have warming shown in red, and that warming occurs about 800 years prior to the CO2 increase. So CO2 is lagging temperature increase by about 800 years. And this has been demonstrated for all these glacial, interglacial interfaces through time. So we're always seeing a lag. CO2 is not driving climate. CO2 is not acting as a greenhouse gas over this very important period of strong climate change. Now we're going to go back over the last 500 million years of Earth history. This, I'm presenting research by Jan Weitzer, my colleague here, and this record shows a decoupling of CO2 and climate over this, what we call the Phanerozoic. And during the Phanerozoic, what Jan has shown is that we've had a series of ice houses and greenhouses. So we've had ice ages and hot houses or warm periods on a rather cyclical time scale over this 500 million year period. But when we look at the correlation with CO2, we see high CO2, and these are various models of CO2 concentrations in the atmosphere. This is a log scale, so at number 1 we're looking at a 10-fold increase of CO2 over today. And so back during our Ordovician glaciation, we had very high CO2. During the Carboniferous, it comes down. This is when we created all these coal beds in North America, and CO2 went to by sequestration. Here's another Jurassic ice age, and CO2 is 5 to 10 times higher than today. So even over this time frame, we do not see a correlation with CO2. We do not see CO2 as a climate driver. But we do see this if we look at the model projections going into the future. Here I'm showing the IPCC model projections from the year 2000 over the next 100 years. And they all climb by about 2 to 3 to 4 degrees Celsius, and these are significant increases in temperatures. How do they model the greenhouse to achieve these temperatures? Well, CO2 is a very minor greenhouse gas. It's a very minor constituent of the atmosphere. It is by far a strong greenhouse gas. The strongest by far is water vapor. And so water vapor is used in these models to drive climate warming. The concept or the model is based on a little bit of CO2 warming, which would be insignificant, is amplified by water vapor, a 2 to 4 time water vapor feedback. And this feedback effect has never been documented. It's never been seen in the geological record, and so it remains an hypothesis that we've based all of our predictions, and this is the only reason why we're predicting global warming. Do the models work? Well, as my colleague Ross McKittrick
Can I just interject 1 second here? I apologize, sir.
No problem.
As you, I think, know, we're being broadcast on the CPAC network and also on the worldwide
I
web.
understand.
And these overheads that you're referring to in your testimony and almost continually are not being shown, unfortunately, on the networks because they're not bilingual. And that's one of our inviolable rules here in the Senate. So,
I understand.
but I think your narrative still makes them understandable.
I have written a testimony that should be published as well.
At some point, sir, you might just, again, we're not all scientists here, only one of us, and not me. You keep talking about greenhouse gases on the one hand, and then you say CO2 is a greenhouse gas, and then H2O factor. Just what? There's a colloquialism out there in the world that's become part of our regular vocabulary, greenhouse gases. But I don't think anybody really knows what they're saying when they say it.
Can I
so if you
describe
could give a definition, it'd be great.
Absolutely. Thank you very much. The planet, and these are the slides that I cut from my talk, the planet without what we call greenhouse gases, with just a transparent atmosphere of nitrogen and oxygen, would be about 32 degrees colder than today. We'd have a planet which would be unlivable, would be frozen. Thanks to one greenhouse gas, which is water vapor. And what water vapor does in the atmosphere is it absorbs the outgoing radiation. When we warm the planet with solar radiation during the day, it emits that radiation throughout the day and throughout the night. So the planet cools. If we trap that outgoing radiation, what we call long-wave radiation or infrared radiation, like what you see on the hot plates in fast food restaurants, the heat is retained in the atmosphere and warms the Earth's surface. So we retain a planet which is now 14 degrees above zero and habitable. CO2 represents a couple percent of that greenhouse gas effect. It's a very minor greenhouse gas. Water does all the work. So when we talk about the greenhouse gases in the atmosphere and accumulating greenhouse gases in the atmosphere, and we focus on CO2, we're being deceptive, because CO2 cannot give us the warming that has been projected. So to project warming, if we feel we have to account for the past century's warming and project that into the future with CO2, we are obliged to amplify that with water vapor. So my graph with a little arrow of CO2 is making the water vapor cycle work. It's preposterous. CO2 is a very minor greenhouse gas, and we're attributing it all the power in the world to move water vapor around as it will. Preposterous.
Giving it a 1 minute warning.
Okay,
Speed up a
I'm
bit, yeah.
closing in on the final here. So the models predict, as Ross pointed out, a hot spot, and this is the classic response of our planet, or should be, to an enhanced greenhouse effect, where we have between the latitudes of 30 north and 30 south at about 12 kilometers in the troposphere, a thumbprint of warming. This is our fingerprint, our thumbprint of greenhouse warming, according to the models, the numerical models that we're told to believe. If we look at the radial sound measurements, these are balloon-based temperature readings, there is no hot spot. In fact, we have cooling. So we might suggest that the models are incorrect. And then we can ask, well, what do the people who run these models say? And here's what they say. And these are the famous leaked emails, which we get an insight to the thinking of the people who are warning us about catastrophic global warming. Thorne from the Met Office at the Climate Research Unit says, observations do not show rising temperatures throughout the tropical troposphere. This is downright dangerous. We need to communicate the uncertainty and be honest. Phil Jones, who keeps the temperature records, hopefully we can find time to discuss this. Phil Jones responds, the basic problem is that all models are wrong. There's not enough middle and low-level clouds, i.e. they cannot model water vapor and cloud formation. And then Wilson pipes in, well, what if climate change appears just to be mainly a multi-decadal natural fluctuation? They'll kill us probably. These people have great uncertainty in their work, but we don't see that when they present it in the IPCC documents. So what is driving global warming? Well, we have to look at the sun, and we have, unlike CO2, very good correlations between solar activity, various measures of solar activity, and temperature. Here again in the Arctic, where Arctic temperatures, and there's all our melting in the Arctic, correlating with solar activity, but not with CO2. And I'll show one last bit of research done by Solanki, published in Nature, where he points out that during the recent decades, the sun's activity has been greater compared to the last 11,000 years. And here's his graph showing a proxy of solar activity over 11,000 years, and it has peaked in the past 20th century when we see this 20th century warming. Well, let's zero in on that last little bit. And here's the last 1,000 years. And here's a bona fide temperature record from the Greenland ice core, a very robust temperature record in blue. And it correlates very well with our solar activity. So we have a reason that our climate is warming. It's not CO2. And if I can just summarize, we find that there's no geological evidence that CO2 has behaved in the past as a significant forcing mechanism. CO2 remains at the lowest level today, range than observed over geological time. I'd like to add that it's more than a benign gas. It's an essential nutrient for life, with only beneficial effects. And our efforts to limit the use of fossil carbon-based energy has solved no environmental problems, yet has created many more, including the accelerated production of ethanol and the conversion of tropical rainforest to tropical palm oil production. And my feeling is that it's time that we turn our attention to real and tangible environmental problems. And thank you very much.